working for anybody yesterday? Because it wasn't working for me.
Yeah, it was totally working for me.
Okay.
What are you guys having problems with?
Oh, yesterday I
Laptop?
I couldn't open the lecture.
Oh, his lecture that he posted?
Yeah, on WIO courses, it wasn't working for me.
Did you go just to the WIO course link or did you go to the Zoom link? Because it wasn't working when I first, just off the WIO web. But if you were to follow the Zoom link, then it totally worked for me.
Okay, well, I'll try that.
Yeah, I guess I don't even know. I haven't even tried it all, so we're gonna give it a couple more minutes, let some people show up. I will not be surprised, especially since I am recording these lectures, if we don't have full attendance during discussion. Okay, so it is 1:10, so we will start. Okay, so first and foremost, I have no idea how loud I am. Am I like an okay volume for everyone? Yes or no? You can use the chat if you don't want to actually talk to me.
Yes.
That's fine. Okay, cool. Awesome. Okay, so I just wanted to start off and kind of go over this course page that I had added. I just found out like 5 minutes ago that a lot of things were locked because I have no idea how to set up a course page on WyoWeb. But hopefully now everything should be up and running. Have you guys all been able to get access to it? Have you seen if you can get access to it?
Are you talking about like my math lab? I had a little bit of trouble accessing it yesterday.
So nope, not my math lab. I created a WYO courses page specifically for our discussion. You guys probably might have even seen it on your like main dashboard. It just wasn't used at all. Okay, awesome.
Yeah,
So
this morning it was locked still, but it's not locked anymore.
okay, cool. Yeah, I realized that I had made a lot of things unpublished, and so then that kind of messed with the layout and everything. But I was really, really sad that this picture didn't show up. That was really a bummer. But this is how it should look for you guys. I'm in student view right now, as you can see. But so the way that I had it set up was like here, down here is all of the information for the discussions. So you can just always click this link to join discussion for every time we have it. Or you could just enter in this meeting ID. At one point I did require a password, but I removed that. So you don't really need this password. But this is just the Zoom information. And then up here, there's a few links basically just to the modules. So if you want to look in the modules, I'm gonna post like the recordings from discussion here. I have all of the quiz keys here and broken up into exam 1 and exam 2. So you guys should be able to see that. So especially since I'm not able to give back quizzes anymore, and moving forward, you're gonna be taking quizzes on my math lab, at least looking retroactively, you can see where you might have gone wrong, where you might have lost points if you remember what you did on quizzes. Here is exam 1, which you shouldn't really need anymore, but I just added it. And then here's a few things for exam 2. I added a formula sheet that is kind of the same thing that you guys saw for the last exam, if you use that at all. If it'll load. WyoCourses is a little slow with everyone using it so much, but it's just a bunch of formulas, some useful information that you could use for the exam. We won't really be using like the note card idea as much since you won't be going to a formal room, but I would still think it'd be a good idea to kind of have that same note card idea, just so you can, because it's kind of a way to review itself. And then there's also this exam review document, which I wanted to upload it on Sunday, so that you guys had a chance to look at it before you came to discussion today, but that was on me. I didn't realize it wasn't published until like 5 minutes ago. So now it's published and it should be up there fine. And then the last thing that I added, which is something kind of new for this class, is using the discussion page. So here, if you guys wanted to, you could like post questions to other students and kind of just work through problems that way. But I won't really be looking at it too much. So if you do have questions for me personally, just email me. But this might be a way for like everyone in the class to interact with each other. But I think that's all I kind of wanted to go over with the WyoCourses page. If anyone who has seen it, do you have any questions about it? Anyone? Okay, so I'm gonna take that as a no. So what we are gonna do is, okay, sorry, just give me a second to figure everything out. But we are just gonna, I'm gonna have you guys tell me any problems that you wanna go over, any questions you have, and we're just gonna kind of work through them together here. This is OneNote. It's kind of the best, most similar option to using a whiteboard since I do have a touch screen. But yeah, so I was just gonna work through any problems, any questions you guys might have. We could go through the review document, but since I don't have like paper copies to hand out to everyone, that doesn't seem as beneficial. That seems more like on your own time, but if you wanna pull it up and look at it and ask me any questions, you're more than welcome to. So let's see. Okay, yeah, the notebook checks. So, okay, yeah, I guess we do have a few like housekeeping things to talk about first as well. So notebook checks will obviously no longer be in person since a lot of people aren't on campus. But so what you're gonna do is you're gonna take a picture or scan your notebooks, and then you'll upload that to an assignment on WyoCourses. And a lot of people have already been submitting those, so you can submit those at any time, but they're due, I think, by midnight, maybe 8 p.m. He's been doing some stuff with 8 p.m., but on that deadline. So it's basically the same idea. It's just you're submitting a picture rather than your physical notebook. And the biggest thing is making sure that the picture quality is good so that we can still read it, but we're still gonna be grading it on the same rubric as last time. The other thing is we won't have discussion on Thursday. It's still kind of the same setup as before, where when you have like the notebook check, you don't come to discussion. So we don't have discussion on Thursday. Are there any other kind of housekeeping questions, like general course questions? Yes, no, maybe? I know the chat sometimes takes a long time to type something, so you are more than welcome to actually talk to me during this. How the exams will work. So yeah, so the exams are gonna be something kind of different. I'm gonna maybe just flip back to my face if you guys don't mind seeing that. I'm trying to not look too rough for not going outside in many, many days. But so the exams will be on my math lab. And I think when I looked, there were about like 12 questions or so, but there is a practice exam up that's supposed to be almost practically identical to the real exam. So you can go on that, kind of walk through that, see how it's gonna go, how long it's gonna take you, because we've never really done exams on my math lab, so we don't entirely know how long it will take students. But it's basically gonna be a lot like your online homework, except once you only get one attempt for each problem. But I think you should still be able to like move through the problems. Like if you wanted to look at the last problem and then go to the first problem, you can do that. But you don't get to like enter into the exam multiple times. Like once you submit it, that's it. And then I think the biggest change is that, like my math lab, there's not a ton of parts. And so a lot of times it's just the one answer. So you have to be really careful when you're entering your answers to make sure that you're not losing any small points. As far as I know, there's not anything with HonorLock. The only way that we're really kind of monitoring you and trying to prevent cheating is having that time limit, because there's so many problems and you only have, I think, an hour to work through them. It's really not within your best interest to try to like Google any information or anything like that. So HonorLock isn't really going to be a thing. It's kind of more of an honor on you, because there is still academic honesty going on in the background with online classes, but we're not really able to monitor that as much, if that makes sense. So it's just like my math lab homework. You're going to go in, you have an hour to work through the problems, you enter your answers, and then you leave. And then that's it. You can't go back in or anything like that, as far as I know. Any other questions?
So basically, unlike the written test exams, it's basically we get it right or wrong. There's no partial credit for work and all that, right?
Yeah, unfortunately. And I did ask him if there was any way that we could go in and award partial credit, but that doesn't sound like that's really an option here. So my best advice for that would be to try to write down all of your work, because then it'd be easier for you to catch a mistake that while you're writing something out, you can see like, oh, I clearly have a negative where I shouldn't. But yeah, unfortunately, it is completely right or wrong. There's really not any partial credit.
Okay.
Yeah. So that's definitely going to be a big change with this exam. And, it might be something where we'll have to look at how grading or how the exams are weighted, depending on what the results are. That is as much as I know about the exam, from the little I've looked at it and a little bit that he's told us about it. Are there any other questions for me?
Do you know how, if we're going to be able to check our answers after we take the exam? Because I know how to do that on my math lab, and it shows us step by step how to get to the answer and where we went wrong. Are we going to be able to do that as well after we take the exam?
That's a good question. I don't think anytime during the time limit, I don't think you'd be able to go back in, even if you've already submitted and see your answers. I don't think that would be the case anyway, but I wouldn't be surprised if a day or two after the exam has been, like everyone has taken the exam, that my math lab, see, this is the thing that's kind of hard. Neither myself or Mr. Weber has ever really used my math lab for exams, so we don't entirely know what all of the features are. So it is, my math lab may offer solutions after a day or two where you could go in and you could see what the correct answer was, what the steps are. I'm assuming you're talking about like the show help or show me the steps feature on my math lab kind of thing.
Yeah.
Yeah. I could definitely see that being a possibility, but I honestly don't know for sure if it is or not.
Okay, yeah, I was just wondering.
Yeah, no, it's a good question. It's a good question, and I'll definitely ask him about it, whether or not that's going to be a feature, or if it is already a feature.
For
Any other-
your
Yeah.
discussions,
Mhm.
is it just gonna be like normal discussion where we'll come at the time and then we'll ask questions and you'll show us how to do certain problems, then we'll just take the test between 8 and 8?
Yeah, so we'll have the full 50 minutes for discussion, which will be kind of nice. We'll be able to work through even more problems than we did before, granted, as long as Zoom is working properly. But yeah, it's going to be the same setup. You guys come with your notebook or your My Math Lab questions. I work through them. I answer your questions. It's probably going to have to be a little bit less interactive than the normal discussion, just with lagging, bad connectivity, the time it takes to mute and unmute or type in a question on the chat. So I probably won't be doing as much with like the what's this next step. But I will try to involve you guys as much as possible like I did before. But as far as the general structure of just coming with questions, going through the work, that's all going to be the same, yeah.
Okay.
Mm-hmm. Any other questions for me? Any math questions for me?
So for the quiz, are we gonna do that immediately after our Zoom discussion, or?
So
Well,
there isn't a requirement to do it right after discussion. You could hypothetically do it at any point during the day from 8 to 8. But I would recommend that you still take the quiz following discussion. But yeah, it's not going to be a built-in part of discussion like it was before, where the last 15 minutes was entirely just for taking the quiz. It's kind of on your own time now when you want to take the quiz. So if you wanted to take it an hour or two after discussion, you could. If you wanted to take it before discussion, I don't know, see where you went wrong during discussion, I mean, you're more than welcome to do that as well. It's kind of totally up to you what you want to do.
okay.
Yeah.
Is there a quiz today?
No, it's just the review. Any other question for me? The quizzes are like timed exactly 15 minutes. So you're gonna have, in some cases, a little bit less time than sometimes I give you in discussion. I know sometimes I'll give you 20 minutes or more, depending on how everything has like played out. But these ones are specifically just 15 minutes. Anything else? And since everything is through My Math Lab, exams and quizzes will be very, very similar to notebook and online homework problems. The way that I've seen the setup is we literally just click like, oh, we want this problem on the quiz. And so you just click what number it is, and that'll be the problem on the quiz. So they're going to be practically identical to your online and notebook. So at least you have that going for you. There won't be a ton of curveballs there. Any other questions for me? Anything at all? Any math questions for me? Anything you guys want to review? It's been a minute since we've looked at chapter 10.
Oh, yeah, I have one.
Chain rule.
Chain rule, yeah.
So what will this exam be? Will it be like all the derivative rules and like the rate of change, or like that kind of change stuff? And then basically like the power rule, quotient rule, all that stuff, right?
Yeah, exactly. It's going to be all of chapter 10. So 10.2, that was looking at derivatives of exponential and logarithmic functions. 10.3 was product and quotient rule. 10.4 was chain rule. 10.5 implicit. And then 10.7, that's the elasticity of demand and the relative rate of change. So it's very, very heavy on the derivatives and the rules for sure. And then like the last little bit will be 10.7.
Okay.
So did you have a problem in mind for chain rule, or just the chain rule problem?
Actually, I would kind of hoping to combine product and chain rule again, because it was
Okay.
still bothering me.
Okay, yeah.
And yeah, just generic problem. I don't have any.
Okay, okay. So why don't I just choose a problem from the chapter 10 review section, which FYI, that is included in your notebook. It's not just 10.2 through 10.7. The chapter 10 review problems are included. So make sure that you don't forget about those. But yeah, I'll just choose a problem from that section and we'll look at one of those. So let me share my screen again and stop the video so that you don't see me messing with my computer. But okay, so let's look at, let's see what problem I want to do. Okay, so we could look at, there's a couple different ones we could look at. Let's do 63 from 10.4. So this is, and please let me know if anything is like lagging at all or you can't see what I'm doing. Can everyone see what I'm doing?
Yeah.
I just wrote 10.463, nothing else.
Yeah.
Okay.
I can see it.
Awesome. Okay, so we are given f of x equals x squared times x minus 5 cubed. Okay, so that is the function we're looking at. So we already kind of know because of why I chose the problem, but what are the two rules we're going to be using here?
Product and chain.
Product and chain, exactly. So order does not matter here, but typically when you have the combo, I like to do product or quotient rule first and then do chain. But like I said, order doesn't matter. So I'm going to break it up the way that we did forever ago, where we looked at what the first function is, what the second function is, and what their respective derivatives are. Okay, so what do you think our first function will be? And since it's product, the order doesn't really matter. We have more time, so I have more time to awkwardly wait until someone responds. Which is a fun bonus for me. Any takers?
Would we put x squared as f for f of x and then x minus 5 for s of x?
Awesome. Yep.
Nice.
And like I said, order doesn't matter, so you really could do it either way. Okay, so x squared is pretty straightforward. That derivative is just 2x. But now this guy, that one's a little bit more complicated. That's where we have to throw in the chain rule component. So let's just try to keep some color coordination. So let's look at derivative of x minus 5 cubed. And if I go too crazy with colors, please just tell me to stop. I make use of my color palette for sure. Okay, so we have our outside and our inside and their derivatives. Okay, so what is going to be our inside function first?
X minus 5.
Yeah, awesome. And don't worry if you guys end up talking at the same time. It's just going to be kind of getting used to everything. So if x minus 5 is our inside function, what does that mean for our outside function?
Inside cubed.
Inside cubed.
Yep, the inside cubed. Awesome. Okay, so x minus 5, that should be pretty simple as a derivative. That'll just be 1. Now, the I cubed, same kind of idea as before. It's the same derivative, but rather than x, we just have the I. So we treat it exactly the same as normal. And remember that when we do chain rule, all we're doing is multiplying derivatives. So we have 3i squared times 1. And then our last step always when we're doing chain rule is just to substitute in our I. This is just a general question, but would you guys like me to post like the OneNote, like the notes that I'm taking?
Yes, please.
Yes, that would help.
Yes,
Okay.
thank you.
Awesome. Yeah, I can do that. Okay, so then that means that we can just plug this guy in right here. So then we'll have 3 times x minus 5 squared. Okay,
And
yeah.
this was the chain rule that we just did, right?
Yeah, this was all just chain rule. So let me write that over here. And then this right here is product rule. Ooh. Okay, awesome. So we have everything laid out. Does anyone remember how we set up product rule?
Wouldn't it be first f prime of x times s of x plus f of x times f or s prime of x?
Perfect.
Nice.
Awesome. Yep, exactly. So then now we have everything we need, so we just plug it in wherever we see stuff. So f prime of x, that's right here. So we have 2x. And then our s of x, so that is x minus 5 cubed, plus our f of x, so x squared times s prime of x. So we have 3x minus 5 squared. Okay. Now, and this is especially important since you're now taking quizzes and exams online, is simplifying your answers. Okay, we want to make sure that we are simplifying things as much as possible, especially when the problem is asking us to simplify. Okay, so what do you think, is there anything that we could factor out, any terms that we have in common here?
X minus 5 squared.
Exactly. So let me just use some more fun colors, really just make it an abstract painting. So we are factoring out our x minus 5 squared. Now what is left over when we factor that out?
2x, x minus 5.
Anything else?
Would you add that x squared?
X squared, is there anything else tagged like
Oh,
combined with the x squared?
Wouldn't it be 3?
3. Yeah.
Exactly. Okay, there we go. Awesome. So then we still have our x minus 5 squared out here. What are we going to do in this inside part?
Gonna distribute.
Distribute, exactly. So we'll have 2x squared minus 10x plus 3x squared. Okay. Write out our x minus 5 squared again. How is that going to combine?
5x squared minus 10x.
Awesome. Okay. Now that we have that 5x squared minus 10x, is there anything we could factor out of that guy?
Could you take out the 5?
X.
We could take out a 5 and, I heard someone say it.
5x?
Yeah, we could take out a 5 and an x. So we'll have 5x out here times x minus 5 squared times what's left over?
X minus 2.
Minus 2. Perfect. Okay. And I think, oh, if we wanted to finish the problem, okay, but before we get to that, are there any questions about any of this? Chain rule, product rule, simplifying? Maybe I'll use another fun color.
So I don't have a question about like this problem, but like, could we go over like the difference between implicit and explicit differentiation? I still am a little confused about that one.
Okay, yeah. So when we are talking about, so let me, like I said, I might go a little crazy with the colors, so bear with me, but I do think it kind of helps. So explicit versus implicit differentiation, okay? So when we are talking about something being explicit, you usually have something that's like y equals or f of x equals. You have everything solved in terms of x. It's y or f of x on one side, everything with x on the other side. So y or f by itself on one side, just writing what I said, and everything in terms of x. And this is still true if you were to have like t or some other kind of variable in there. But the idea is still just that you have something solved for. You don't have a combination of what seems like two variables in one equation.
Okay.
Now with implicit, that is where you don't have anything solved for. So these look like an equation with two variables. That's where you would have like x and y together or x and t, something kind of like that. You're not gonna have your y equals your f of x equals. It's gonna be like x plus y squared equals, sometimes, a lot of times just a number. A lot of times when you see implicit, it's just a number equals. So when you're doing explicit differentiation, okay, so this is just your normal derivative rules. So you don't have to do anything different there. You're just gonna have your y prime equals f prime of x equals, it's still the same kind of idea. But then with implicit, for that guy, anytime you see so anytime you see a y, you're using a chain rule. And you have the added step of solving for your y prime or your dx dt. Same kind of idea. It doesn't really matter what letters you have in there. It's the same kind of idea. Anything that's explicit, you don't have to do any solving for any other variables. Everything is already solved for in a nice condensed package. And implicit always has that extra step of having to solve for the derivative. Does that kind of answer your question?
Yeah.
Okay, awesome. Anything else you guys want me to go over? We still have about 20 minutes.
It looked like somebody put something in the chat.
Did they? That doesn't notify me, which is fun. Let's see. Yes, okay. Okay, cool. Yep. So going over kind of just some stuff from 10.7, a couple of different concepts. So first and foremost, looking at our relative rate of change. So let me click to it. Okay. So looking at relative rate of change. So relative rate of change, that is when you're taking, there's two different ways to write this. So either derivative natural log of f of x, that's one way to write it, or equivalently, it's the derivative over the function. And it's a way to compare growth rates of functions. The example that was in the book was looking at two different stocks. If you were to buy stock in one company versus another, which is more profitable, that kind of idea. But this is kind of the general setup for relative rate of change. It's just the derivative over the function itself. Now, when you're combining that with elasticity of demand, because it goes hand in hand. So that is, so we have EP. That is the negative relative rate of change of demand over the relative rate of change of price. Okay. So when we are talking about looking at an approximate change of demand, we can use this equation and solve for a rate of change of demand. So when we're just strictly solving for relative rate of change of demand, we can just move some things around and we get that the relative rate of change of demand equals a negative elasticity of demand times the relative rate of change of price. Okay. But a lot of times we're not actually looking for the relative rate of change of demand exactly. What we're looking for instead is the approximate. And remember that this triangle, this delta symbol, that means change. So when we are looking for approximate change in demand, we're gonna alter this equation a little bit, but we're still gonna have the same idea. This will stay the same. It's still gonna depend on our elasticity of demand. But now, rather than multiplying by the relative rate of change of price, we're just gonna be multiplying by the change in price. Okay, so is everyone with me on this idea?
Yeah.
Let me see if there are any questions. Okay, cool. So looking at problems 51 and 53 from the homework, the same kind of idea for both of them. So it's talking about if the $12 price is increased by 4%, what is the approximate change in demand? Just to give us some numbers to work with. So do you guys want to go through and actually find what the elasticity of demand is for this problem, or just how you set up this problem?
Is there a possibility we can do both?
Sure, yeah. So, okay, so then let's look at 7, 51. So we are given P plus 0.004x equals 32. And this isn't super needed in the problem, but we are given a domain. So if we want to find elasticity of demand, first and foremost, what do we need to have?
Don't we need to find the derivative?
Before we have the derivative, we need a function, right? Do we have a function right now?
Oh, we need
No.
to solve for x, right?
Yes,
Or
exactly.
P in the-
We need our demand equation solved in terms of price. So what that means is we need to solve for x. Okay. So we can move this p to the other side. Okay. And then when we divide by 0.004, I have this off to the side here, we should get 8,000 minus 250 p. Okay. So that's just kind of first steps. We need a demand equation. Okay, so then we have our f of p, which is what we need for elasticity of demand. Okay, so set it in plain terms what our elasticity of demand is, but what is it as a formula, like a closed expression? Started you off with the negative at least.
I'm not really sure what you're asking.
So what is the expression for elasticity of demand?
Oh, it's
The derivative over the original
Yeah.
function.
Really close.
and
What are
then
we-
multiply the top by P.
Yep, there we go. Exactly. Okay, so we have our f of p here. Oh, sorry, Caleb. It doesn't notify me when there's a new comment in the chat. Okay. So we have negative p. What's going to be this derivative of this function here?
Just negative 250.
Negative 250.
Mm-hmm. Divided by just the function itself. Okay.
The demand function that we found, not
Yeah,
the original function. Okay.
Yes, yes, exactly. You want to use this guy right here. Okay. So we will have 250 e divided by 8,000 minus 250 p. Okay. Now a step that is completely optional but sometimes simplifies your work a little bit is you can simplify this if you wanted to. What could we divide by, or how could we simplify it?
250.
What would we have?
We'd have 1 or just P on top, and then 32 on the bottom.
What did you say on the bottom?
I said 32.
Yep. Awesome. Okay. So now we have our elasticity of demand equation. So the first thing that it asks us is what is the elasticity of demand when the price is $12? Okay, so how can we find that?
Would we just
Looking
plug
12.
in 12?
Substitute
Exactly.
12 for p. Yeah.
Yeah, exactly. And this is why I like having this more simplified form here, because it makes, when you plug in the number, a lot easier to do in your head. What's 32 minus 12?
20.
Okay. Can we simplify
than
the
one.
fraction at all?
3/5.
Mm-hmm. Do you know what 3/5 is as a decimal?
Less than 1.
It is less than 1, but we weren't looking for whether something's inelastic or elastic. We do actually want the actual value here.
It's 0.6.
Yep, exactly. The way that I remember that is you always double the numerator when you're looking at that decimal.
I have a question for the exam. When you want us to do the answer for this, would you prefer us to have it in a decimal or a fraction?
So it entirely depends on the computer. If you are ever told use like 1 decimal place, 2 decimal places, always use a decimal. And given that this is a class that is looking at applications of calculus in business specifically, it is a good habit to get into to use the decimal whenever possible, because most of the time you'll be talking about real units where it makes more sense to use decimals rather than fractions.
Okay.
But I would say if the problem is ever asking for the exact answer, if they ever say use the exact answer, you want to use a fraction. Because say you had something like 1/3, this is exact, where 0.33, that's approximate. So if they're ever asking for exact answers, that's when you want to use a fraction. But any other time, you should be fine using a decimal.
Okay. That
Any
makes
questions on
that
that
makes sense.
front? Okay, cool. So that is our elasticity of demand. And elasticity of demand doesn't have units. So we just say elasticity of demand is 0.6 when the price is 12. If you were ever asked to like write a sentence for your answer. Okay, now we want to look at approximate change in demand. Okay, and this is where this formula comes in that we have up here. We're looking for approximate change in demand when the price is 12, but we're going to increase the price by 4%. Okay. So we know from this equation that we're going to start off with our negative e of 12. That's what we already have. That's what we've already found. So that kind of gives us our starting value. And we always plug in the price that we're starting at into this elasticity of demand. And then we're going to multiply by whatever the price is changing by. And we can actually just leave this as a percent. We don't need to change it to a decimal or anything. Okay, so you just simply have your elasticity of demand times your percent change in price. So then doing that, we get negative 0.6 times 4%, which gives us the approximate change in demand is negative 2.4%. So if you wanted to put that into words, that would be saying that if the $12 price is increased by 4%, demand will approximately decrease by 2.4%. So I'm going to write that here.
Quick question. How do you know when to use or like put the negative in front of the E?
So you always use the negative because there's a negative here.
Oh, okay, I see.
Yeah, so when you're rearranging this equation, you keep that negative.
Okay.
So that's why you use, oh, let me get rid of that one. So that's why you use a negative down here. Ah, that was gross, sorry. That's why you use that negative. But say instead that your price was decreasing rather than increasing, you would also have a negative there. So that's just kind of that general idea. So you can kind of already see that if you're going to increase price, demand is going to decrease. And if you're going to decrease price, demand is going to increase because the negatives will cancel out. It's just by a matter of what percent. Any other questions on this problem? We have about 2 minutes until discussion is technically over. But can I answer any last minute questions for you guys? Anything more about the exam, this problem? Anything? Let's see if there are any. Well, if there aren't any questions, you guys are free to go, but I will be available via email. And remember that I have my office hours tomorrow. I'm now doing 2-hour-long virtual office hours via Zoom on Mondays and Wednesdays from 1 to 3 p.m. and that's Mountain Time. And so all I'm doing is I'm just sitting on Zoom waiting for someone to just join the meeting. That's all it really is. So if you guys do have any more questions, you're more than welcome to reach out to me during my office hours, since you do have some flexibility on when you want to take the exam. But yeah, anything else? Any words of wisdom that I can give you guys? Okay, so I will say that is probably the end of discussion. Thank you all for coming and good luck on your exam.
All righty. Have a good one.
Yes, you too.